Okay, so these are questions from the Unit 3 exam. Sorry, did I wake you up? All right, so this question asks you to sketch the graph with the following properties. So the first one says, part A says continuous for all real numbers. All of them show continuous. It's differential everywhere except for at x equals 2. All of them show it's differentiable except for x equals 2. You know, all four of them have a little cusp. That's where it means it's not differentiable. F of 1 equals 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They probably all have 5. 1, 2, 3, 4, 5. I think so. All right. They tell me on D that f prime of 1 equals 0 and f prime of 3 equals 0. So what does that mean? On part D, f prime of 1 and f prime of 3 equals 0. That means x equals 1 and 3 are critical points. Right, so they have horizontal tangent lines or they're not differentiable there. But we already know it's not differentiable at 2. So at 1, it should have a horizontal tangent line. So like I like this one, looks like it has a horizontal tangent line, right? Oops. This one looks like it has a horizontal tangent line. Yeah, that one does too. Yeah, that one kind of does too. Let's look at 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so they all kind of look like they have horizontal tangent line. All right, on part E, it says f prime of x is greater than 0 on 1 to 2. That means it's increasing from 1 to 2. All right, so from 1 to 2, this one is not increasing, right? It's decreasing. So we can definitely get rid of A, right? Because it is decreasing there. B is increasing, C is increasing, D is decreasing. So we can get rid of D. Part F says f prime of x is less than 0 on negative infinity to 1, 2 to 3, and 3 to infinity. All right, so that means it's decreasing on all of those intervals. All right, so from negative infinity to 1, well, I think that takes out B, right? Because from negative infinity to 1, well, from 0 to 1, it's increasing. From 2 to 3, it's decreasing. And 3 to infinity, it's increasing. So we can get rid of B. All right, so we know that the answer is C, but let's continue. On part G, it says the limit of f prime of x as x goes to 2 from the left equals infinity. The limit as x goes to 2 from the right of f prime of x goes to negative infinity. All right, so that is going what that says is the derivative is undefined at 2. So f prime of 2 is undefined. But they kind of already told us in part B that it's not differentiable there. So in other words, we have a cusp, but we already talked about that. Now on part H, it says f double prime is greater than 0 on negative infinity to 2, 2 to 3, and 4 to infinity. That means on those intervals, it's concave up. All right, so from negative infinity to 2, definitely concave up. From 2 to 3, yeah, concave up. 4 to 8. So really only in this section right there is it concave down. And that's probably what I tells us. The second derivative is negative from 3 to 4. And yes, so that means from 3 to 4, it is concave down. And that is it for that question. Next question, a rectangular tank with a square base and an open top and a volume of 8,788 cubic feet is to be constructed of a sheet of metal. Find the dimensions of the tank that has the minimum surface area. All right, so I have a tank with a square base. So both of these links are the same. And we'll call the height y. And they tell me that the top is open, so I don't have a top, I just have a bottom. Find the dimensions of the tank that has the minimum surface area. Okay, so this is my base. X times X is my base. And then these are my sides. So X times Y. And I have 4 of these and 1 of these because I don't have a top, I just have a bottom. So my surface area is the base plus the 4 sides. All right, so x squared plus 4xy. All right, this is my primary function because this is what I want to minimize. All right, I want to minimize my surface area. All right, they tell me that the volume is 8,788. All right, so that is going to be my constraint because right now my primary function has 2 variables. So my volume is length times width times height. 2 of those, length times width times height. So 2 of those are x's, 1 is y, and that equals 8,788. I'm going to solve for y. So y equals 8,788 over x squared. All right. Now I'm going to plug that into my primary function. And then we are going to minimize it. Right, so my surface area in terms of x is going to be x squared plus 4x times 8,788 over x squared, which is x squared plus 4 times 8,788. Gosh, big numbers. 35,152 over x. All right, so now we're ready to take the derivative. So s prime of x is equal to negative 2x minus 3,152 over x squared. We're going to set that equal to 0. I don't know why I have a negative 2x. It should be a positive 2x. So I have a 2x is equal to 35,152 over x squared. Let's multiply both sides by x squared. So I have a 2x squared is 2x cubed, is equal to 35,100. Man, all right, let's try that again. 2x cubed is equal to 35,152. And let's divide that by 2. 17,576. And I'm going to take the cubed root of that, or just raise it to the 1/3 power. And I get 26. All right, so if x equals 26, then y equals 8,788 divided by 26 squared gives me 13. Now, really, we should check to make sure that that is a minimum. So you can put that on a number line. And let's do the first derivative test. All right, so plug in 1. If I plug in 1, I'm going to get a negative number. If I plug in 1,000, I'm going to get a positive number. So that is going to well, I can't get 1,000, but if I plug in 27, let's try 27. That's going to give me a positive number. Okay. Now it asks for the dimensions, so that is going to be one side of y and two sides of x. So a 13 by 26 by 26. So that is my answer. All right, next question. The marginal profit in dollars on Brie cheese sold at a cheese store is given by P prime equals x times 80x squared plus 60x, where x is the amount of cheese sold in hundreds of pounds. The profit is negative 90 when no cheese is sold. All right, so we want to find P of x, and I know P of x is equal to the integral of P prime of x, and they give me the initial value that P of 0 equals negative 90. All right, so I'm going to integrate x times 80x squared plus 60x. Let's distribute my, let's distribute my x. So I get an 80x cubed. Uh-oh, everyone needs attention at one time. All right. 80x cubed plus 60x dx. So if I integrate, I get 80 over 4, which is 20x to the 4th, plus 60 over 2, which is 30x squared. Wait a minute, did I write this down right? Oops, this had an x, so this should be squared. Let's repeat. 60 divided by 3 is going to give me a 20x cubed plus a constant. Now I'm going to plug in 0, and I get 20 times 0 to the 4th plus 20 times 0 cubed plus c equals negative 90, which means my constant equals negative 90. So p of x is exactly 20x to the 4th plus 20x cubed minus 90. All right, that was part A. Part B was to find the profit from selling 400 pounds of brie. Now remember, in the directions, they say X is the amount of cheese sold in hundreds. So I'm going to plug in 4. So P of 4 is equal to 20 times 4 to the 4th plus 20 times 4 cubed minus 90. So 4 to the 4th times 20 plus 20 times 4 cubed minus 90. And I get 6310. And that was part B. This is part A. And that is it for that question. All right, next question. It says graph the function considering the domain, the critical point, symmetry, relative extrema, regions where the function is increasing and decreasing, inflection points, and so on. All right, so the first thing I'm going to do is I'm going to look at the function. All right, and the function can tell me, what can f of x tell me? F of x can tell me the domain. It can tell me my asymptotes and my intercepts. So that's what I'm going to start with. All right, my function is f of x is equal to x plus 6 over negative x plus 2. All right, I'm going to start with the domain. I know it's defined everywhere except for x equal to 2. So my domain is negative infinity to 2 and 2 to infinity. All right, my asymptotes. I have a vertical asymptote. at x equals 2. I have a horizontal asymptote at y equals -1. All right. And then let's take a look at our intercepts. So I have x-intercepts when y equals 0. So if y equals 0, I have x plus 6 over negative x plus 2. I'm going to multiply both sides by negative x plus 2, and that's just going to leave me with an x plus 6. So I'm going to get an x-intercept of -6. So -6, 0. If I want to find my y-intercept, then I'm going to let x equal 0. If I plug in x equals 0, then I get 0 plus 6 over 0 plus 2, which is 3. So I get 0, 3. All right, so those are my intercepts. Oh, tiny. I have lots of distractions tonight. So I should have, I don't think that gets rid of, okay, we're gonna pause. Pause recording. Okay, I think we settled down a little bit. All right, so with just the intercepts, I believe that we can take out D. I thought I saw another one. Well, maybe that's it. All right, I guess that's it. All right, so why don't we go ahead and take the first derivative. And remember, with the first derivative, we can find where it's increasing and decreasing. We can find our critical points. And we can find our extrema. All right, so let's use our quotient rule. I'm going to take the derivative of the top, which is 1 times the bottom, negative x plus 2, plus the top times the derivative of the bottom, which is negative 1, over the denominator squared. And let's distribute that negative 1. So negative x plus 2 minus x minus 6. Uh-oh, did I make a mistake here? Let's look one more time. Oops, this should be a negative sign. There we go. So I should have, this should change both of these signs. So plus x plus 6 over negative x plus 2 squared. And I get an 8 over a negative x plus 2 squared. Now, we have critical points where it's undefined and where the first derivative is 0, but the place where it's undefined is not in our domain. So negative 2 is, or 2 is not a critical point, and it's not going to equal 0 anywhere. So when I put it on the number line, the only place that I'm going to include is going to be my discontinuity. Remember that we include our discontinuities on our number line. So we're going to include where we have our asymptote, which is at 2. And let's go ahead and let's just notice that the top is positive and the bottom is always positive too because it's squared. So it's increasing from negative infinity to 2 and 2 to infinity. And I don't have any critical points and I don't have any extrema. All right, so let's take a look at our picture or our graphs. And it looks like part C has decreasing after the asymptote. So we can get rid of C as well. All right. And then I think we can also get rid of B because they don't have a horizontal asymptote at -1. So B is gone as well. So we know that the answer is A, but let's go ahead and go on to the second derivative and talk about concavity. So here's my first derivative. And let's just remind ourselves what the second derivative can tell us. The second derivative can tell us our points of inflection, right? Points of inflection. It can tell us concavity. And then it can also tell us extrema. All right, so let's go ahead and take the second derivative. I'm going to rewrite the first derivative as 8 times -x plus 2 to the -2. So that I don't have to use the quotient rule. So I'm going to bring down my -2 and I get a -16, -x plus 2, subtract 1 from that power, which gives me a -3, times the derivative of the inside. So I'm just using chain rule. So -1, which gives me a 16 over -x plus 2 cubed. Now again, if I set this equal to 0, I'm not going to come up with any values of x that make it equal to 0. So I don't have any possible points of inflection, but we always do include our discontinuities on our number line. So I'm going to include 2. If I look before 2, let's say 0, I'm going to get something that is positive, right? If I plug in 0, I'm going to get something that's positive. So I'm going to have concave up. If I plug in something after 2, say 5, I'm going to get something that's negative, so concave down. So it's concave up before 2, and so concave up before the asymptote and concave down after the asymptote, which is what we have here on A. Right, and that is it. All right, question 12. Find the absolute extrema if they exist, as well as the values of x where they occur, for the function f of x equals 3x to the fourth minus 150x squared plus 1 on the domain -6 to 6. So my function is 3x to the fourth minus 150x squared plus 1. So I know that if I'm on a closed interval, I will have an absolute max and I will have an absolute min, and they either occur at the endpoints or at the critical points. So I'm going to find my critical points. So 12x cubed minus 300 x. Can I factor out, let's see. Oh, wait a minute, here's my calculator. I grabbed my phone. So I'm gonna factor out a 12x. So that gives me a x squared minus 25. So 12x, x minus 5, x plus 5. So I have critical points x equals 0, -5, and 5. All right, and then I have endpoints -6 and 6. So unfortunately, this one is going to require us to check a lot of points. So I need f of -6, I need f of -5, I need f of 0, I need f of 5, and f of 6. If I plug in -6, what do I get? So I have 3, and these are all to the even power, so I should get the same thing for -6 and 6, and for -5 and 5. So 6 to the 4th minus 150 times 36 plus 1. So I'm getting a negative 1,511. Right, and I'm going to get the same thing for f of 6. 0, I get 1. For -5, so 3 to the 4th minus 150 times 25 plus 1. So I get a negative 1,874, and I get the same thing for 5. All right, so my absolute max is 1. It occurs at x equals 0. My absolute min is negative 1,874. It occurs at x equals -5 and 5. All right, and that is it on that one. All right, suppose that the graph below is the graph of f prime of x. This graph is f prime of x, not the graph of f of x. The derivative of f of x is given. So this is not the function, this is the derivative of the function. Find the open interval where the original function f is concave up or concave down. Find inflection points, any inflection points. All right, so I'm going to start with finding the second derivative. So they gave me the first derivative. I can find the second derivative. So I'm going to get 4x cubed over 3 minus 9x squared minus 14x. I'm going to set that equal to 0, and I'm going to factor out an x. So I get a 4/3 x squared minus 9x minus 14. All right, so possible points of inflection are x equals 0. And then to find the others, I'm going to have to use the quadratic formula. So x equals negative b plus or minus b squared minus 4ac, whoops, 14, over 2a. So let's see what we get here. So I have an 81. I have two negatives, so I'm going to say plus 4 times 14 times 4 divided by 3. Pretty ugly number. So let's start by adding that one to 9, plus 9. Notice the bottom is 8/3. So if I multiply by the reciprocal, that would be multiplying by 3 and dividing by 8. Whoops, I made a mistake somewhere. Let's try that one more time. All right, 81 plus, oh, I multiplied by, okay, let's try this again. 16, oh, I know what I did. 81 plus 16 times 14 divided by 3. Plus 9 times 3. What do I keep messing up? Okay, let's try it one more time. Oh, I forgot to take the square root. That's what I keep doing wrong. All right, 81 plus 16 times 14 divided by 3. Take the square root of that. Uh-oh. Second answer. Right, I'm going to add 9. Now I'm going to multiply by 3 and divide by 8. And I'm getting 8.053741818. And they are telling us to round to 1 decimal place. So that's going to give me an 8.1. So I have an 8.1. Now I need 9 minus the square root of 81 minus, whoops, 16 times negative 14 divided by 3. Times 3 divided by 8. Right, and I am getting a negative 1.303741818. So x equals negative 1.3. All right, so those are my x values. A lot of people are saying they're looking at the graph and trying to guess exactly, but you can find the exact values by using the quadratic formula. Now we're going to put those on a number line. So I have a negative 1.3, I have a 0, and I have an 8.1. So if I plug in something before negative 1, so say negative 2, And I plug that into my second derivative. So let's plug that in here. So I'm going to get a 4/3 times 4 plus 18 minus 14. So that gave me a positive number times a -2. That's going to give me a negative number. So I'm negative here, which means concave down. The other way we could tell, if we look at the original function, right, it's the derivative is decreasing, so we should also know that it's concave down. Now, if we look between negative 1.3 and 0, let's say -1. So I have a 4/3 plus 9 minus 14. That gives me a negative number times a negative number. That gives me a positive number, so that is concave up. Let's go ahead and plug in a +1. So I'm going to get a 4/3 minus 9 minus 14. And times the +1 in front, that's going to give me something negative, so that is concave down. And after 8.1, we should get concave up because it's increasing, but let's check just in case. Let's plug in 10. So 4/3 times 100 minus 90 minus 14, and we get concave up. So we get, because it changes concavity at every single point, we get points of inflection at -1/3, 0, and 8.1. It is concave up from -1.3 to 0 and 8.1 to infinity. Whoops. I think they want you to separate it by a comma, so forget the union sign. Concave down, -infinity to -1.3, and oops, try to use that union sign again, 0 to 8.1. Right, and that's it. Next question. For y equals the square root of 5x plus 7, find dy given x equals 3 and the change in x equals -0.07. Right? Dy is approximately f prime of x times the change in x. Right? So if y equals the square root of 5x plus 7, let's write it as 5x plus 7 to the 1/2, then y prime is 1/2 5x plus 7 to the -1/2. The derivative of the inside is 5. So 5 over 2 5x plus 7 to the 1/2. All right, so dy is approximately 5. Let's evaluate it at x equals 3. So 2 times 5 times 3 plus 7 to the 1/2 times my change in x. They tell me the change in x is negative 0.07. All right, so I have 5 times negative 0.07 divided by, put that in parentheses, 2, put this in parentheses as well, 15 plus 7, raised to the, and put this in parentheses, 1/2, close parentheses, close parentheses, close parentheses, whoops. And I am getting negative 0.0373100125. And they say round to the nearest thousandths, so 10 100,000ths. So I want to round to that one. The number before is 3, so I'm going to get negative 0.037. Next question. All right, so looks like we have an optimization problem. A campground owner has 1,800 meters of fencing. He wants to enclose a rectangular field bordering a river with no fencing along the river. See the sketch. Let X represent the width of the field. All right, so I'm going to let this be X, so that means that side is X as well. And let's just let that be Y, or you can call it W, doesn't matter. So I'm going to come up with, I'm going to come up with a primary function. All right, so my area is what I'm trying to maximize. Yes, okay, so my area is going to be X times Y. That's my primary function. And then my constraint is going to be the perimeter, because I have 1,800 meters of fencing, but one side has the river. So I have 2x plus y equals 1,800, right? Now, they want us to answer these in a certain way, write an expression for the length of the field as a function of x, all right? So they want this as a function of x. So y equals 1,800 minus 2x. So that's what they want there. So let's replace this with 1,800 minus 2x. Now they want us to find the area of the field, length times width, as a function of x. So now they want us to rewrite our primary function as in just with variable x. So I have x times 1,800 minus 2x. All right, part C says, first write the expression for the derivative used to find the value that maximizes the area. So let's first go ahead and distribute this x. Now let's take the derivative, a prime of x, which is the same thing as dA dx. So I get 8, Triggy, you're being loud. Yeah. 1,800 minus 4x. Okay. All right. And find the x value that leads us to the maximum area. So I'm going to set this equal to 0. So I have 4x equals 1800 divided by 4, and I get x equals 450. Now I know that that is going to give me a maximum because the second derivative gives me a negative number no matter what, which means my function is concave down everywhere. So that critical point is going to give me a maximum. All right, let's see. And then the maximum area. So now we just want to plug my x value into my area function. So 450 1800 minus 2 times 450. So is that what? 450 times 900? Right, and I'm getting 405,000. And that's it. All right, next question is suppose a of t equals 15 halves square root of t plus 7e to the negative t, d of 0 equals negative 7, and s of 0 equals 12, find s of t. So they give me the acceleration, they give me the initial velocity, they give me the initial position, and they want the position function. So I know if I want the velocity function, I need to integrate the acceleration function. Whoops, let's use t's. Plus 7e to the negative t dt. All right, so I'm going to add I'm going to add 1 to 1/2, which gives me 3 halves. I'm going to divide by the same number. Whoops. All right, now I'm going to divide e to the negative t by the derivative of the exponent, right? The derivative of the exponent is -1. So I'm going to divide by -1. Let's just make that negative 7e to the negative t plus a constant. Let's multiply by the reciprocal. So 15 halves times 2/3 t to the 3 halves minus 7e to the negative t plus a constant. So my 2's cancel and 3 goes into 15 5 times. So I have 5t to the 3 halves minus 7e to the negative t plus a constant. Now they tell me that v of 0 equals -7. So v of 0, so 5 times 0 to the 3 halves, minus 7e to the 0 plus 7 equals -7. All right, well, e to the 0 is 1. So I have -7 plus c equals -7, which means c is exactly 0. So my velocity function is now 5t to the 3 halves minus 7e to the negative t. All right, now we're ready to find the position function. And the position function is the integral of the velocity which is 5t to the 3 halves minus 7e to the negative t. I'm going to add 1 to 3 halves, which is going to give me 5 halves. And I'm going to divide by the same number. And again, I'm going to divide by -1, which is now going to make that positive 7e to the negative t, plus my constant. Multiply by the reciprocal, so 5 times 2/5, e to the 5 halves, plus 7e to the negative t, plus my constant. My 5s are going to cancel. And my position function is 2e to the 5 halves plus 7e to the negative t plus a constant. And they tell me that s of 0 equals 12. So s of 0 equals, why do I have e to the 5 halves? That is a t to the 5 halves. I need to go to bed. Okay, t times 0 to the 5 halves plus 7e to the 0 plus c equals 12. So I have 7 plus c equals 12, which means c equals 5. So my position function is 2t to the 5 halves plus 7e to the negative t plus 5. All right, next question. All right, so I have the integral of 1 plus 7t to the 6th over 2t. All right, so the key on this one is to separate it into two fractions. So 1 over 2t plus 7t to the 6th over 2t. So 1/2 times 1 over t plus 7/2 times t to the 5th. All right, now 1 over t, the integral of that is the natural log of the absolute value of t. And t to the 5th, I'm going to add 1 to the exponent, which gives me 6. I'm going to divide by that same number. So I'm going to have a 6 times 2, which is 12. So I'm going to have 7 over 12 t to the 6th plus a constant. Hey, Tiny, it's time to go to bed. Go night-night. Oh, did I put the constant? Yes, I did. Okay. All right, next question. Find the demand function for the marginal revenue function. Recall that if no items are sold, the revenue is 0. Okay, so they tell me that R of 0 equals 0 so that I can find the constant. They want me to find the demand function, not the revenue function, right? But they gave me the marginal revenue function. So I can find the revenue function from the marginal revenue function. By integrating the marginal revenue function. So 0.06x squared minus 0.07x plus 212x dx. I integrate 0.06x squared. I add 1 to the exponent, which is 3. I'm going to divide by the same number. So 0.06 divided by 3 is going to give me 0.02, 0.02x squared. And I'm going to add 1 to 1, and that's going to give me 2.0 divided by 2, 0.07, whoops, 0.035 x squared plus, oops, 212x plus my constant. And they tell me r of 0 is equal to 0. So 0 squared, 0 cubed times 0.02 minus 0.035 times 0 squared plus 212 times 0 plus the constant equals 0, which means my constant is exactly 0. So r of x is equal to 0.02x cubed minus 0.035 x squared plus 212. Now, they want us to find the demand function, and I know r of x equals x times the demand function. So if I want to find the demand function, I need to solve for p of x. So p of x is equal to the revenue function over x. All right, so my demand function is, oh, I erased my revenue function. It was 0.02x cubed minus 0.035x squared plus 212x over x. Divide each of those by x, and I get 0.02x squared minus 0.035x plus 212. That's my demand function. All right, next question. Find the open intervals where the function x squared plus 9 is concave upward and concave downward. Find any inflection points. All right, so I have f of x equals the natural log of x squared plus 9. So I want to find the second derivative. So the first derivative is going to be the derivative of the inside, which is 2x over the inside. Now I want to take the second derivative. I'm going to use the quotient rule. So the derivative of the top times the denominator minus the numerator times the derivative of the denominator over the denominator squared. That doesn't sound good, does it, Flux? All right, so let's distribute in the numerator. So I have a 2x squared plus 18 minus 4x squared over x squared plus 9 squared, which gives me a negative 2x squared plus 18 over x squared plus 9 squared. All right, so let's first just notice that The domain is going to be all real numbers because x squared plus 9 is always greater than 0, right? There's no number that I can plug into x that will ever make that negative, okay? So it's all real numbers. Now I'm going to set that derivative, the second derivative, equal to 0. Guys, I'm almost done. All right, notice again, the denominator can't equal 0 either. Multiply both sides by the denominator so that I have negative 2x squared plus 18 equals 0. So 2x squared equals 18. X squared equals 9. So x equals plus, plus or minus 3. All right, and then it says type an ordered pair. All right, so they want the x and y value as an ordered pair. So the x value 3, if I plug in f of 3, I get natural log of 3 squared plus 9, which is natural log of 18. Right, so 3 natural log of 18. And then if I plug in negative 3, I'm going to get the same thing, natural log of 18. So those are my two ordered pairs. Now they want to know where it's concave up and concave down. So I'm going to put my two possible points of inflection. So really, I shouldn't say those are my points of inflection yet because I should check to make it sure it changes concavity. But let's put negative 3 and positive 3 on my number line. Notice the denominator is always going to be positive. So if I plug in something less than negative 3, say negative 4, I'm going to get 16 times negative 2, and that's going to give me something negative. So that's going to be concave down. If I plug in 0, the top is going to be positive, so I'm going to get concave up. If I plug in something bigger than 3, then I'm going to get 4. Or if I get bigger than 3, say 4, I'm also going to get something negative. All right, so it does change concavity. So both 3 and negative 3 are points of inflection. And it is concave up between negative 3 and 3, and concave down between negative infinity and negative 3, and 3 to infinity. All right, we have another similar problem where they give us information about the function, but they don't give us the function. All right, so part A says it's continuous and differentiable everywhere except x equals 2, where it has a vertical asymptote. So the only one that doesn't have a vertical asymptote at x equals 2 is B. So I know it's not B because they have a vertical asymptote at negative 1. It says f prime of x is greater than 0 everywhere it is defined. All right, so that means it's increasing everywhere it's defined. All right, so if I look at C, C is decreasing everywhere it's defined, so it's out. And D is decreasing everywhere after its asymptote, so it's out. So the answer is A, but let's go on. It has a horizontal asymptote at y equals -1. All right, that one has a horizontal asymptote. It says the second derivative is greater than 0. Second derivative greater than 0 means it's concave up. So it's concave up from -infinity to 2 and 4 to 6. So this little portion in here and all of this is concave up. And then it says the second derivative is less than 0, which means concave down. From 2 to 4. So after the asymptote here, and then from 6 to 8. So here and here. Then this part is concave up. All right, so our answer is A. All right, so this one says find the minimum value of the average cost for the given cost function on the given intervals. All right, so they said find the minimum value of the average cost. They gave us the cost function. We need to find the average cost function. So if my cost function is x cubed plus 32x plus 250, then my average cost function is the cost function over x. So x cubed, did I write that function down right? Yes. Plus 32x plus 250 over x, which is x squared plus 32 plus 250 over x. So let's go ahead and take the derivative. And I get a 2x minus 250 over x squared. We're going to set that equal to 0. And I get a 2x equals 250 over x squared. Let's multiply both sides by x squared. So that I get a 2x cubed equals 250 and divide by 2, 125. And if I take the cubed root, I get 5. So now what I'm going to do is I am going to check the endpoints and I'm going to check that critical point. So C of 1, C of 5, and C of 10. So if I plug in 1, I get 1 plus 32 plus 250. 283. If I plug in 5, I get 25 plus 32 plus 250 divided by 5. 107. If I plug in 10, I get 100 plus 32 plus 25. So 157. All right, so the minimum value of the average cost is going to be 107 on that interval between 1 and 10. All right, now part B, I guess it doesn't have parts, but it asks for the minimum value of the average cost over the interval 10 to 20. So now my critical point isn't in that interval. So, oh man, I just erased my function. There we go. All right, so we already found C of 10, so let's go ahead and find C of 20, the average cost of 20. So 20 squared plus 32 plus 250 divided by 20. All right, I get 444.5. All right, so that means C of 10 is the smallest. So 157. All right. I guess we didn't do this one. All right, so it says sketch the graph of a single function that has all the properties listed. Continuous and differentiable for all real numbers. All right, that's true for every single one of those graphs. F prime of x is less than 0 from negative infinity to negative 3 and from 2 to 6. So it's decreasing on those two intervals, decreasing. Right, so it should be decreasing from negative infinity to negative 3. So I believe we can get rid of B and C because they are increasing on those intervals. All right, F prime of x is greater than 0 on negative 3 to 2 and 6 to infinity. So that means it's increasing from negative 3 to 2 and 6 to infinity, right? And I think they're both doing that. Both A and B are doing that. Part D says the second derivative is greater than 0 from negative infinity to 0. That means concave up. So negative infinity to 0 is concave up, and 3 to infinity is concave up. They both look like they're doing that. On 0 to 3, part E says it's concave down. From 0 to 3, 0 to 3. Yeah, they both look like they're concave down there. Part F says F of negative 3, F prime of negative 3, and F prime of 6 equals 0. So that means that they have critical points. If they are continuous and differentiable, that means they must all have horizontal tangent lines there. All right, then it says F double prime of 0 equals 0 at 0.15 and 3.14. So that means they have possible points of inflection. So let's see what's going on here. Negative 3 and 6. So let's check these points a little bit better. So -3, go away, whoops. Right, -3 and 6. Now 0, 15 and 3, 14. I wish I could blow these up a little bit more. Okay, so -3, are these by, so that's -3. 1, 2, 3, 4, 5, 6. I guess it's close enough. Okay, so that is definitely not -3, 6. So that one's out. All right, so this one was actually a little bit harder to eliminate, but it is A. And I think that's our last one. All right. Best of luck studying.